Good morning, students. Good morning, students. Today we'll discuss long answer question from intermediate first year. Expression for time period in simple pendulum. This is the question number 3. I said yesterday, total 6 LAQs you are reading for upcoming supplementary examination. Up to now, 2 questions I finished. First question, law of conservation of energy, freely falling body with bullet problem. Second question, define work kinetic energy, work energy theorem with power of motor problem. Question number 3, today topic, expression for time period in the case of simple pendulum. This is the third 3-star question for annual examination, upcoming examination. So, time period. Time period of simple pendulum. Derive the expression for time period of simple pendulum. First of all, simple pendulum. This is the simple pendulum diagram. Length of simple pendulum. This is the rigid support. Thread, metallic bob. One metallic bob suspended with string, suspended with thread from rigid support. This system we are calling simple pendulum. Simple pendulum time period. What is the expression for capital T in the case of simple pendulum? Length of pendulum small l. Just we are applying external force capital F. Capital F is the external force applied on metallic bob. It executes, it makes, it gives simple harmonic oscillation like this, to and fro oscillations. So, simple pendulum diagram with length L making angle theta from A to B point. What is the displacement means? X. So, simple pendulum, external force capital F. Here we are writing mg divided into 2 components. One is the mg cos theta, second one is the mg sin theta. So, this is the mg sin theta. Mg, weight, downward force, upward force. Mg, nothing but gravitational pull, we are calling weight. Mg divided into 2 components. One is the mg cos theta, second one is the mg sin theta. Our topic, expression for time period in the case of simple pendulum. So, pendulum length L, external force capital F. We are applying force like this F. Capital F equals to, right side force equals to minus mg into sin theta. Why we are writing minus means external force right side mg sin theta, component of mg left side, both are opposite direction. That is why we are writing minus. One more component there. This is the equation number 1. One more component, upward force T, downward mg cos theta. So, tension and mg cos theta both are balancing each other. Our topic about F is equal to mg sin theta. Why we are taking mg sin theta means, here when we are applying external force right side, body making oscillation like this left side, meaning mg sin theta is the responsible for motion. That's why left side component mg sin theta, right side component f. We are taking this equation 1. Upward force, downward force cancel each other. So from equation number 1, F equals to minus mg sin theta. From equation 1, you know very well about F equals to ma. Substitute here. Ma equals to minus mg into sin theta. M gets cancelled. Remaining steps, A equals to minus g into sin theta. A equals to minus g into sin theta. This is the equation number 3. First diagram, simple pendulum diagram. This is the length. L is the length of simple pendulum. It makes theta angle. When we are applying external force capital F, it executes simple harmonic oscillations. External force capital F, right side, mg sin theta, that is the component of mg, left side. So right side force, left side force, directions opposite. That's why we are taking one is the plus, second one is the minus. Remaining two terms component mg cos theta and tension cancel each other. From equation 1, F equals to ma, external force formula. A stands for acceleration, m stands for mass. F is equal to ma equals to minus mg sin theta. M cancel each other. A equals to minus g into sin theta. From equation number 3, we can get our time period equation. A equals to minus g sin theta. Now here, A equals to minus g into sin theta. Sin theta, approximately theta. What is the meaning for this one? Means mathematically one condition we are applying from mathematics. Sin theta, cos theta, tan theta. Any angle you take, angle small means that given angle approximately equals to theta. This one mathematical condition. So according to our case, minute. Say, say theta, practically that value less than 5 degrees. That's why we are treating theta, nothing but sin theta, approximately theta. Theta L, x is the displacement. So sin theta, approximately theta means we are writing A equals to minus g into theta. You know, SHM condition, simple harmonic motion acceleration formula, A equals to minus omega square x. Acceleration directly proportional to displacement with opposite direction. So A equals to minus omega square x. This is the SHM condition. You apply this condition here. Minus omega square x equals to minus g into theta. Theta meaning say theta equals to angle theta equals to arc per length, meaning theta angle equals to arc per length. Theta equals to x by L. This one also mathematically we are using sin theta equals to opposite side by adjacent side. So theta equals to opposite side, nothing but theta equals to your angle. Angle equals to arc per length. Theta equals to x by L. You apply here. Theta, nothing but angle equals to arc per length. Minus cancel, x cancel. omega square equals to G by L. See here, generally this one like this, sin theta only. Theta quite opposite x, hypotenuse L. So sin theta equals to opposite side by hypotenuse there here. Theta equals to x by L. Same we are taking mathematical condition. Sin theta instead of sin theta, theta angle equals to arc per length. Now see here, omega square equals to G by L. Then what is the omega means? Under root of G by L. Omega stands for angular velocity. Angular velocity and angular frequency both are same. Omega equals to under root of G by L. Omega stands for angular velocity. Angular velocity, angular frequency, both are same. Omega equals to under root of G by L. Our topic, time period. Time period, capital T equals to 2 pi by omega. Capital T is equals to 2 pi by omega means omega under root of G by L. This one we are taking reciprocal. Capital T equals to 2 pi under root of L by G. So overall student, expression for time period capital T equals to 2 pi under root of L by G. Now see here, first time period of simple pendulum, little bit introduction we are writing about simple pendulum. A metallic bob suspended from rigid support with a thread with a string. Simple pendulum length L. External force capital F. When we are applying external force capital F, it makes simple harmonic oscillation. When it makes simple harmonic oscillation, we are calculating what is the time period of simple pendulum. Making angle theta, F external force, T upward force tension, F right side force. Generally tension upwards, mg downwards. Mg nothing but gravitational pull, weight of the body. Weight of the body downwards, tension upwards. F right side there, mg divided to two components. One component mg sin theta going towards left side, right side capital F, mg sin theta balances with capital F. F equals to mg sin theta. Direction opposite. That's why we are taking one value plus means one value minus. Here minus indicates opposite direction. Tension T balances with mg cos theta. From equation 1, F equals to minus mg sin theta. Left side F is equal to substitute ordinary force formula MA. M cancel. A equals to minus g sin theta. A equals to minus g into sin theta. Acceleration equals to g into sin theta. Here we are applying mathematical condition. Generally sin theta means going like this. Just imagine. 1 minute. See. You treat this is the right angle triangle. Sin theta. Here theta. Theta quite opposite x. Here L. Sin theta equals to opposite side by hypotenuse there. So sin theta equals to opposite side x. Sin theta equals to opposite side by hypotenuse L. This one only we are writing theta equals to x by L. Mathematically we are taking angle equals to arc per length or x length L. Theta equals to x by L. X stands for displacement. L is the length of simple pendulum. A equals to minus g sin theta. Now A equals to minus G sin theta approximately theta. Here we are applying angle theta equals to arc per length. So A equals to minus G into theta. A equals to minus G into theta angle equals to arc per length. Minus cancel. X cancel. Omega square equals to G by L. Omega equals to under root of G by L. Omega stands for angular velocity. Angular velocity, angular frequency, both are same. Omega equals to under root of G by L. Time period formula T equals to 2 pi by omega. Omega we got from this total derivation part under root of G by L. So omega you write under root of G by L. Going towards reciprocal we are taking, students. Capital T is equals to 2 pi under root of L by G. This is the expression for time period in the case of simple pendulum. This total answer now I am giving in short method. How to get this derivation part, how to solve this derivation part in easy way. Within 4 to 5 steps, we are getting this answer. Time period equals to 2 pi under root of L by G. This is the expression for time period, including this time period. Sometimes they are giving two special cases. One is the definition of seconds pendulum. Second one, ticks of pendulum. First of all, T equals to 2 pi under root of L by G. I will give you in short method. Here students, this is the steps how to read, how to derive the time period equation in easy way. Short method, students, here. First, draw simple pendulum diagram. Here, just annual examination purpose, depend on scheme of evolution, you are getting marks. Same points I am giving. Draw diagram, length L, theta. Here, mg, external force, tension, mg cos theta, mg sin theta. What is the arc means? X. Here, student, external force equals to minus mg sin theta. F equals to mg into sin theta. You know very well about F is equal to ma, because that is the very famous formula from Newton's second law. M cancel. A equals to minus omega square x. This is the SHM condition. So you write minus omega square x equals to minus g into sin theta. Direct you write, otherwise here theta in bracket you write sin theta approximately theta. So minus cancel, student. Omega square x is equals to g into theta, meaning x by L. Angle equals to arc per length. MPC student, this one I think no problem for you. Sin theta only. Sin theta means opposite side by hypotenuse. We are going that one only. Theta equals to x by L. Left side omega square x. X cancel. Omega square under root of g by L. Then what is the time period formula? 2 pi by omega. Overall you substitute after reciprocal under root of L by G coming. So student, this is the way for how to derive time period equation in simple way. See, only derivation part coming. For this one you add matter. What is the matter? A simple pendulum with mass m suspended from rigid support. Over. Then after draw diagram, mg divided into two components. For this diagram in examination you can get 1 mark, individual mark, students. Then after angle length diagram over means external force equals to this one right side. External force equals to restoring force. What is the step you are writing? External force. External force balances with restoring force. One is right side, one is left side. Right, F is equal to ma. M cancel. Left side A, SHM condition. Then after minus minus cancel. Angle equals to arc per length. Based on which condition? Angle very small means sin theta, cos theta, tan theta. All angles equals to arc per length. Depending on that condition, we wrote omega is equals to under root of G by L. Time period equals to 2 pi under root of L by G. This is the question number 3 LAQ for upcoming examination student. In this one, we are getting two cases. One case, definition of seconds pendulum. Case number 1, what is seconds pendulum? They're asking what is seconds pendulum. Seconds pendulum. See student, this one only seconds pendulum. Time period equals to 2 seconds. What is the meaning of time period means? For example, one point A, one point B. One person going from A to B, again coming from B to A. This is called time period. Initial point, again final point, both are same. Morning, you are coming from your house to college. Morning, you are from house to college. Again, you are going from college to house by evening. This is called time period. Meaning time period equals to 2 seconds. For example, one simple pendulum. Going from A to B, again coming from B to A, it takes 2 seconds. That pendulum we are calling seconds pendulum. Seconds pendulum means time period of a simple pendulum is 2 seconds. So we are writing T equals to 2 seconds. Time period T equals to 2 seconds. That pendulum we are calling seconds pendulum. Now, here student, one more in this one. Ticks of pendulum. What is the meaning for this one? Means length. What is the length of seconds pendulum? Previous we got from that derivation, overall derivation we got capital T equals to 2 pi under root of L by G. Squaring on both sides. We are getting T square 4 pi square into L by G. T square, seconds pendulum, 2 seconds. 2 square means 4. 4 pi square. Pi square value approximately 10 student. Pi square value, small g value, both are same. Small g equals to 9.8 meter per second square. Small g value, pi square value, both are same. So we are taking g value approximately 10. That's why I took 10 into L by what is the g value? Acceleration due to gravity 10. 10 cancel. 4 cancel. L equals to 1 meter. Nothing but 100 centimeter. This one only ticks of pendulum. L equals to 1 meter, 100 centimeter. So total 2 cases coming from this simple pendulum case. One is seconds pendulum definition. Second one, ticks of pendulum. Up to now, seconds pendulum with ticks of pendulum and time period over. For this one problem. Sometimes we are getting problem for this derivation of simple pendulum. So student, one more time I will give you explanation from starting onwards. First, seconds time period of simple pendulum. Time period of simple pendulum means diagram of simple pendulum. Little bit matter, just 1 to 2 lines. Enough matter. A simple pendulum, mass M, suspended from rigid support. Over. A simple pendulum suspended from a rigid support. Then after diagram. L is the length, theta is the making angle, external force, capital F. When we are applying external force, it makes simple harmonic oscillations. Mg divided into 2 components. One is the mg cos theta, left side mg sin theta. So External force equals to restoring force. That is the step. This one. F equals to minus mg sin theta. You know F equals to ma. Substitute F is equal to ma. Minus minus cancel. A is equal to omega square x. M cancel. So overall A equals to minus g sin theta. This minus nothing but A equals to minus omega square x. That is upcoming case, student. So F is equal to ma. You write F is equal to ma. Cancel. A equals to minus g into sin theta. See here. F is equal to minus mg sin theta. F is equal to ma. This is the brief explanation, shortcut explanation for time period equation. That's why direct you write F is equal to ma. M cancel. What is the simple harmonic motion acceleration formula? Means A equals to minus omega square x. Minus omega square x. Substitute here. Minus minus cancel. Omega square x. G angle equals to arc per length. X cancel. Remaining angular velocity. Omega equals to under root of G by L. Then what is the overall time period? Time period equals to 2 pi by omega. Capital T equals to 2 pi under root of L by G. So students, next, seconds pendulum. Seconds pendulum means time period capital T equals to 2 seconds. That pendulum we are calling seconds pendulum. If T is equals to 2 seconds, that pendulum is called seconds pendulum. Over. Ticks of pendulum, you take time period formula from simple pendulum, squaring on both sides, left side T square, right side 4 pi square. Pi square means 10, T square means 2 square 4, 4 cancel, 10 cancel, L equals to 100 centimeter. In intermediate secondary, every MPC come BPC student, they are doing simple pendulum practical. What is the length of simple pendulum? Means maximum we are taking 1 meter. Reason this one only. More than 1 meter, nothing will happen. So what is the length of seconds pendulum? Means 100 centimeter. For this one, now we are doing one problem. Say here, same oscillation. What is the page number? Here, students. Here, page number 214, 214, 214, exercise problems. Problem number 11. Problem number 11. Calculate the change in the length. Calculate the change in the length. Change. Change means delta L. Okay. Change means delta L. Final value minus initial value. Calculate the change in the length of simple pendulum of length 1 meter. L1 equals to 1 meter. Given data, given length 1 meter. When its time period of oscillation changes from 2 seconds to 1.5 seconds. Time period changes from 2 seconds to 1.5 seconds. From this given data, what they are asking means calculate the change in the length. Delta L equals to question mark. So length 1 meter, time period changes from 2 seconds to 1.5 seconds, meaning decreased. You know, T equals to 2 pi under root of L by G. T with L, T directly proportional to root L. T directly proportional to root L. We are writing T1 by T2 equals to L1 by L2. T1, 2 seconds. T2, 1.5 seconds. L1, 1, L2, we don't know. So remove this point. 3/4 equals to 1/L2 student under root. Squaring on both sides. Squaring on both sides. 3 square means 9, 16, 1/L2. From this one, what is the L2 value? 16/9 meter. Because we took SI value. L2 equals to 16/9. What they're asking? Change in the length. Change in the length means L2 minus L1. L2 16/9. L1 1. 16/9 is there. 1 minute. Here 16/9. Delta L equals to minus 7/9. Wait, one second. Nine by 16 equals to 1/L2. L2 is equal to 16/9. Correct all. L2 is equal to 16/9. Delta L equals to 16. We got now 9 minus 1, 9 LCM. Minus 7/9. Here I think they gave mistake. So minus 7/9 meter decrease. Minus indicates that value decrease. Again, I'm repeating, student. Calculate the change in the length. L1 equals to 1 meter and time period of oscillation changes from 2 seconds to 1.5 seconds. L2 is equal to question mark. T1 by T2 is equal to L1 by L2. Then T1 means 2 seconds. T2 means 1.5. L1 means they give 1 meter. L2 we don't know. 4, sorry. 1 minute, wait, student. Just wait. I took one small mistake. Wait. I took reciprocal value. Here 4/3 equals to 1/L2. 16/9 squaring on both sides. L2 equals to 9/16. Okay. So delta L equals to L2 minus L1. 9/16 minus 1. 7/16 meter is the answer. Decrease. Minus coming. That's why answer they gave 7/16 meter decreased. 7/16 meter decreased means this minus indicates decrease. This is the fixed problem for time period of simple pendulum. Delta L. What is the question? Change in the length. Change in the length. So minus indicates that value decrease. Now, here student, this is the case number 1. Seconds pendulum. Seconds pendulum meaning time period equals to 2 seconds. That is seconds pendulum. This one case number 1. All this one possibility. Ticks of pendulum, length of pendulum. T equals to 2 pi under root of L by G. T equals to 2 pi under root of L by G. Squaring on both sides. T square equals to 4 pi square into L by G. Substitute every value. We can get L is equal to 1 meter. Possibility number one, define seconds pendulum. Sometimes they're asking define seconds pendulum with fix of pendulum. What is the last case mean this problem? Change in the length. Calculate change in the length. What is the given data? Length of simple pendulum 1 meter. Its time period changes from 2 seconds to 1.5 seconds. What is the change in the length? This is the question number 3. Meaning, sometimes they're asking just expression for time period. Sometimes case number 1, fix of pendulum. Case number 2, seconds pendulum. Case number 3, change in the length. That's why you go and you read 3 cases. T1 is equal to 2 seconds. T2 is equal to 1.5 seconds. T directly proportional to root L. T1 by T2 is equal to L1 by L2. Time period 1, 2 seconds. Time period 2, 1.5 seconds. L1, 1, L2, we don't know. So remove point, we can get 0, 5, 3 is a 5, 4 is a. Here only, by mistake, I took reverse previous case. 4 by 3 is equal to 1 by L2 under root. Squaring on both sides, 16 by 9 equals to 1 by L2. L2 equals to 9 by 16. Up to here, this is the final length. Question, change in the length. That's why we are going one more step. Delta L equals to L2 minus L1. Present we got 9 by 16. Previous from data 1 meter. What is the balance? 16. 9 minus 16 there. So 7 by 16 meter. Here minus indicates that length decreased. That's why we are writing this one. So students, total 6 LAQs. This one third LAQs. Now here I'm giving first question onwards. What is the question? What is the problem? What is the question? What is the problem? Total 3 questions, including problem. Now I'm giving explanations here. Say, all of you focus on these 3. From these 3, 100% 1 LAQ coming in upcoming supplementary examination. First one, law of conservation of energy. Law of conservation of energy in the case of freely falling body. Statement. This one all we are going in shortcut method. Law of conservation of energy, very old statement I am giving explanation because every student you know this one. Energy neither created nor destroyed. Energy neither created nor destroyed. But energy changes from one form to another form. This is the statement of law of conservation of energy, freely falling body. After that, diagram. A body falling freely. A body falling freely. Every LAQ we are having diagram. So M is the mass of the body. Body falling from small h height. This is A. This is B. This is C. You take this is the capital H. Total small h. This gap capital H. What is the balance? H minus H. So point A, point B, point C. Calculate A, B, C. Total 3 points. A point, B point, C point. Student, A, potential energy means mgh because height of the body small h. Kinetic energy means 0. What is the reason? A body falling freely. A body dropped. That's why initial velocity 0. Overall energy EA equals to mgh. Equation number 1. This one our day 1 explanation. Point B. This point B. What is the height? Capital H. That's why we are writing potential energy means mgh. Kinetic energy means half mv square. Half mv square meaning we are getting 2g into h minus h. So overall 2 cancel, mgh minus capital mgh. So at point B, potential energy means mgh, kinetic energy means mg small h minus mg capital H. Overall energy B. This term cancel each other because of potential energy plus kinetic energy. Overall mgh. Equation number 2. This is energy at B point. Now students, energy at C point. C point. Here on the ground, potential energy m into g into what is the height? 0. Kinetic energy half m v square. V square meaning 2as. 2 acceleration due to gravity g. S displacement h. 2 cancel. So overall energy C mgh plus 0. From 1, 2, 3. From equation number 1, 2, 3, energy conserved. That's why we are writing always energy at A point, B point, C point remains same. What you are writing? From equation 1, 2, 3, energy conserved. This one, our first class problem, bullet problem. For this one, bullet problem, student, I already gave explanation. Once you check, power is equals to work done per time. This is the required formula. Number of bullets 360, mass 5 gram, velocity 600, like that they are giving. So this is the bullet problem. This is the law of conservation of energy with bullet problem. This is our day 1 first LAQ. Now, second LAQ, yesterday topic. Define work, kinetic energy, work energy theorem. Work denoted with capital W. Work always equals to dot product of force and displacement. Next, kinetic energy half mv square. Energy received, energy possessed, a body with respect to its motion. So one is the work definition, one is the kinetic energy definition. Units same, joules. CJS units, ergs also there. Scalar quantity. Then after work energy theorem statement. Work done by the force. Work done by the force always equals to change its kinetic energy. So work equals to half mv square minus half mu square. You know, v square minus u square equals to 2s. Here one diagram, student. The diagram your choice, because for this diagram no mark. Initially, one body m mass initially moving with u velocity. When we are applying external force capital F, its velocity changes from u to v. So v square minus u square equals to 2s. Both sides multiply with m by 2. Then we are getting our equation. M by 2 into v square minus u square. Right side 2as into m by 2. 2 cancel, student. Remaining our answer. Half mv square, half mu square, ma into s. Ma, mass into acceleration equals to force. This is force into displacement. Half mv square minus half mu square. Force into displacement, nothing but work. Half mv square minus half mu square. This is the work done is equals to change its kinetic energy. For this one, 2 problems. every long answer with problem. One is bullet, machine gun bullet, 360 bullets problem. Second one, power of motor in watts. Yesterday I gave explanation. One more is there, power of motor in horsepower. What is the power in horsepower? Two fixed problems for this one. Any one you are getting in examination. This is the second elective. One is power of motor. We did yesterday 15 kilowatts. Second one, balance. That one will do within few minutes. Power of motor, I think 170 HP. This one. Now we are doing this problem soon. This is the second elective work kinetic energy, work energy theorem. Today class, time period of simple pendulum. Time period of simple pendulum T equals to 2 pi under root of L by G. Total 3 special cases there for this simple pendulum case. First case, definition of seconds pendulum. Time period equals to 2 seconds. That pendulum we are calling seconds pendulum. Case number 2, ticks, length of pendulum. Third one is there. What is the change in the length? Previous we did 7/16 with minus coming. What is the change in the length of simple pendulum? 7/16. This is the question number 3. First of all, this one in old book student, few mistakes there you see. In textbook only we are having small mistakes. Work, energy, power, page number 141. Problem number 2, a machine gun fires 360 bullets. That answer 5.4 kilowatts. That is correct. Question number 3, find useful power used in pumping. That answer they gave 2.68 into 10 square HP. That answer wrong. 170 HP that answer. And one more, question number 4. Yesterday we did this one. A pump is required to lift 600 kg of water per minute. That answer they gave 12.5 kilowatt. But answer 15 kilowatts. In old textbook student, this one 2 years back textbook. So just to change these answers. One is machine gun, correct. Find useful power used in pumping. That answer they gave 2.68. One more, a pump required to lift 600 kg. That answer they gave 12.5, but answer 15 kilowatts. So last one problem left for work energy theorem. What is the power of motor in HP? HP nothing but horsepower student. Now you see. Page number 141. Question number 3. Find the useful power used in pumping 3425. 3425. Volume 3425 meter cube. This is the volume of water per hour. So time they gave 1 hour. 1 hour equals to 3600 seconds. 1 hour equals to 60 minutes. 1 minute is equal to 60 seconds. 60 into 60, 3600 seconds. So this one given data per hour from a well 8 meter deep. Depth they gave 8 meter. Suppose 40%. Suppose 40% of the horsepower during pumping is wasted. Out of 100%, 40% waste, meaning remaining percentage 60%. Total 100. 40% waste, 60% utilizing. So power, 60% of power utilizing. Now, what calculate the power required to perform the above task. They're asking what is the horsepower of engine. So we are calculating P. You know, student, horsepower. General life, you know, bike, CC, Bajaj Pulsar. Example, take Bajaj Pulsar bike, 150 cc, 225 cc. CC, nothing but cubic centimeter, volume of engine. Sports bike, bus, car, train engine. We are going big vehicle means that engine power calculated in HP. HP indicates horsepower. 1 horsepower equals to 746 watts. Why we are writing this one means in present problem they're asking power of motor in HP. In HP means horsepower they're asking. That's why we are writing. So 60% of P power equals to work done per time. You know, on removing percentage, we can get 100. W equals to mgh. With respect to configuration, work convert into potential energy. So 0, 0 cancel, 2, 3 ja, 2, 5 ja. 3/5. P equals to mgh/t. From this formula, we don't know what is the m value, but they gave volume, water, they gave water case. So density equals to mass per volume. This is the density. In 10th class, we are using small d notation. D or rho, this one rho, looking like P model, rho. Rho equals to mass per volume. Then mass equals to density into volume. Mass equals to density of water 1000. This is the constant value. In examination, they are not giving. Density of water 1000 kilogram per meter cube. 1 gram per cc. In serious units. Volume 3425. Already they gave. So m equals to 1000 into 3425. 3425 into 1000. This is the mass term. G value, obviously, you know, 10. Height, depth, 8. Time, 3600. From this one, we need what is the P? 2 zeros cancel. Otherwise, we will do direct student because this power we are calculating means we can get watts, but asking in horsepower. 1 watt equals to this one into. We are taking towards left. Into means by. 1 watt equals to 1/746 horsepower. 1 watt equals to 1 divided by 746 horsepower. Because of horsepower, we are doing this calculation. Without this one, we can get in watts. But now we need answer in horsepower. That's why student 3/5 P. Remaining steps I am writing. 1 minute. Here. This is the mass G. Three by 5 P. Mass G. Depth 8 meter. Here. This is the density. This is the volume. G 8 by 3600 into 1 by 746. 60% of power m g h by time into 1 by 746. Here students, same value I wrote 60 m g h by time into 746. 2 zeros cancel. 4 twos are 0, 0 cancel, 2 threes are 2 fives are 3 by 5 p equals to 10 into 10 100 3425 into 100 into 2 by 9 into 746 7 fives are 7 fours are approximately 4.5. So this one take left 4.5 into 100 into 2 into 5 by 27. 3 coming left 9 into 3 27 p 4.5 100 into 2 200 this one 5. Now CR this is 1000 P equals to 15 into 1000 divided by 90. What? Huh? Okay. 1500 divided by 9. So student P equals to 166.6 horsepower. This answer approximately you take in examination 170 HP. No problem. This is the power of motor in horsepower. Okay. So finally, 3 LAQs for work energy theorem, 2 problems, 1 problem, power of motor in horsepower 170 HP, previous problem 15,000 watts. Now, see our students. Say this is your LAQ zone, long answers for upcoming supplementary examination. 19-bit purpose, you are reading 2 questions. Law of conservation of energy with bullet problem. Next, define work, kinetic energy, work energy theorem. 2 problems, student. One is 15 kilowatts. Second one, 166.6 horsepower. This is for 19th. 20th purpose, time period of simple pendulum. Time period of simple pendulum. One is ticks. Second one, seconds pendulum definition. Next one, change in the length 7 by 16. This is time period 1, 2, 3. In 3 days, 3 LAQs over. From this 3, 100% you are getting 1. Minimum 1, maximum 2. More 3 questions left, student. Here, define SHM. show that particle motion SHM when it is performing in circular motion. So circular motion concept. This one upcoming LAQ. Last two questions from thermodynamics. One is Newton law of cooling. One is Newton law of cooling with surrounding temperature problem. Every LAQ we are getting with problem. So Newton law of cooling with fixed problem, surrounding temperature. Last one is there, reversible, irreversible process, Carnot engine. Total 6 LAQs you are reading. From that one, minimum to maximum 3 questions coming. You need 2. This is 19. I made frame direct. This one 19th with purpose. This one 20. This one 21. This question I finished today. 1, 2, 3. Half of LAQs over. Out of 6, 3 LAQs over. More 3 LAQs balance. So this one finished part. This one balance. Define SHM, Newton law of cooling, reversible, irreversible process. 3 LAQs left. Then after we are going towards SAQ zone. Every student compulsory you read 6 LAQs. That is 6 LAQs. This one only. So we'll continue tomorrow.